Hi, uh, good morning. Uh, we finished last time talking about the start of the scientific revolution with the initiation of the Royal Society, which started in 1664, and the pioneers such as Christopher Wren and Robert Boyle, and followed by astronomers such as Hubble and his sister who was his able assistant. And along with that, we talked about Joseph Banks, who traveled to see the transit of Venus with James Cook to Australia and was instrumental in guiding Royal Society for almost 40 years and was involved in founding of the Kew Garden. Now, obviously, this was not all adventure and science for the sake of learning alone, because there were commercial interest, because from the plants that they brought from the wide corners of the world, which helped the British Empire as it was taking hold, such as bringing quinine from South America and providing it for malaria protection all across the new colonies such as India and Africa. And subsequently, similarly, they managed to secretly ferret away the rubber plant and from Brazil and tried to establish it in various areas such as Ceylon, which is Sri Lanka, and later on in Malaya, and in turn ended up ruining the whole export economy of Brazil. Okay, now, so we'll continue with this. And in the description, we talked about the Copley Medal, which was the oldest scientific award, which was started only a few years after the establishment of Royal Society. It was given by a rich businessman for the outstanding achievement in any field of science and without any. And to their credit, it was not restricted to just Brits alone, but even non-members and foreigners were allowed to accept it. And the list of the Nobel winners of the, I'm sorry, Copley Medal winners is like the who is who of modern science, people who made our modern life, starting from the first foreigner, which was Ben Franklin, and followed by some of the even the heavens, the Frenchmen like Louis Pasteur was awarded with Nobel Prizes. And second, then obviously the well-known names such as Darwin, Louis Pasteur, and Joseph Lister, and and so the list is a very illustrious people who founded the modern world. And it took them for a long time for to recognize women as ability, and it was until into the 20th century. And unlike Nobel Prizes, it's not restricted just to one or three individuals, and the criteria are not as rigid. Even an entire group can be awarded. For example, most recently in 2019, the AstraZeneca group was awarded the Copley Medal uh, for the vaccine development. And one of the first winners for this was a guy that if we may recall, self-taught scientist who did experiments on electricity with making a boy hanging from the silk rods and rotating. And now now this is accompanied by a $25,000 pound award. So this is, the longest winning legacy of recognition of science in the regular world. And obviously, we talked at length about in the history of medicine class, but Joseph Lister, who revolutionized modern surgery, he was a son of a successful wine merchant, amateur scientist, and worked with microscopes. And again, the religion played a big role in how people were treated at that time. He was a Quaker, and therefore he was a no-no to admission to Oxford University. He saw the first surgery under ether anesthesia, which was, by the way, was started in United States. And I'll have a slide for that later on, probably. And he was inspired by Louis Pasteur's work on inflammation and used a coal tar to protect ship that was done to protect from barnacles. And so that gave him an idea that distillation of that yielded to phenol, or i.e. carbolic acid. And he used that to liberally spray the surgical field and to prevent infection. And voila, that was successful, and the wounds healed nicely. And that was the start of what we came to be known as antisepsis. And he recognized the role of inflammation, because in the older days, the pus was considered a sign of successful healing, which was obviously a sign of infection. And suppuration was considered necessary for healing of any wound. So he changed the approach to surgery, and even Queen Victoria herself had an abscess, which Lister was able to treat with the under antisepsis. So he had the quotation that he was one of the only living or regular mortals who was able to stab the royalty and get away with it. So, and here was his article that was published in the prestigious British Medical Journal, stating the effectiveness of antisepsis. And this is different from asepsis, which was advocated much later. And again, now obviously he was, as it happens with a lot of Brits who were scientists, he did not commercialize it, but it took up for a dentist in America named Joseph Lawrence, who marketed Listerine, a solution for bad breath, and made lots of money for it, and the product is still around. Now, if we had to pick one particular scientist who was instrumental in or the 19th century, it has to be Charles Darwin. Obviously after people like Hubble and people like William Herschel and other people had their heyday, but Charles Darwin is the most prominent scientist who revolutionized our thinking of human evolution. And obviously, now he was did not want to be a medical doctor. He felt he was not cut out for it, and was inspired by botany. And at a young age of 23, was appointed as a naturalist to travel for the expedition that took place and to South America for natural sciences and studying of botany. And this was his journey, as you can see, that it was a rather several months long trip, starting from Plymouth all the way to coast of South America, and later on to Galapagos Island, and going around the world, basically. So it was a pretty arduous journey. Now, it helps to be rich when you're doing science, because he had a rich father, and his father, Erasmus Darwin, or grandfather rather, he was a poet and a very successful physician, and even on his wife's side, he was inherited the Wedgwood China fortune, so he was able to pay his own way. And after observing the birds and on the Galapagos Island, and seeing the various natural flora and fauna, and seeing the almost naked human beings in South America, he had come up with the idea of natural selection by and evolution. Obviously, this goes along with his botanist training, and he extended the idea to zoology, and also to, lo and behold, to human beings. This was a quite contradiction to the established church teaching at that time, and wisely he decided to wait on it. He had extensive notes, and after his long journey, he had various physical problems and settled down as a rich upper-class gentleman in his estate. And obviously, he was involved in the Royal Society, but did not manage to actively attend the meetings. But he had a mentor, a guy named Huxley, and it happened that in the 1850s, a paper came in from the Dutch colony of Indonesia, or the Dutch East Indies, it was called, and that proposed the same idea that Darwin had of natural selection, and that was by a gentleman named Arthur Wallace. And unlike Darwin, Wallace was not independently wealthy. He had first traveled to South America to collect specimens, but came to misfortune and the ship capsized. So then he decided to seek fortune in the Dutch East Indies, and again had come up with the idea of natural selection on his own. And when his paper came in, Huxley alerted Darwin, and finally a compromise was settled, and both the papers were read at the Royal Society meeting. Now, to Wallace's credit, there was no animosity between the two, and Wallace actually looked up to Darwin as inspiration because Darwin's work was well known in scientific circles, and so this was and no so both papers were published at the same time. And obviously, the tendency that is there in science nowadays as to there is no prize for number two, and so that's they publish the data amicably. Then Darwin obviously gets the credit, and Wallace is now basically a footnote to science. And this was his original tome, The Origin of Species. And obviously, everything else was accepted except for the origin of humans, because based on the church teaching, humans were at the peak of the creation of God's creation, and obviously the idea that humans could have anything to do with apes was hard for people to fathom. And the same statement that we talked about for Isaac Newton applies very much to Darwin as well. Okay, that he changed the whole paradigm shift. And the controversy continued to brew, not just in Britain, but also in the United States, as we know by Cope's trial, okay, that took place in Tennessee. And so, and the great debate took place with the advocate of anti-slavery movement, Reverend Wilberforce and Thomas Huxley, and to settle the argument as to whether humans were related to great apes or not. And again, so now it is, quote unquote, no longer a theory as far as the biologists and people who have an open mind to accept. Except in the United States, it's still creationism is very much in vogue. But we're digressing. So now at the same time, Darwin knew that there were some issues with his theory of evolution, because obviously he was not aware of anything such as gene as to how the hereditary principle is being transmitted. Obviously, it had to wait for several decades, and the work was done somewhere in 1879 by a monk named Gregory Mendel, but that was far out in Eastern Europe, and obviously and it was published in different languages, and so he was not aware of the advances that were taking place. And Gregory Mendel's work was lost to posterity for several years, and was reinvented by Dutch and German botanists. The name that is important is Hugo de Vries, and later on, the fruit fly experiments were carried out by Thomas Morgan, and proving that there is such a thing as genes, and it's not just a figment of imagination. It is not valid just for plants, but it's also valid for eukaryotes. And now on the other front, there were some advances that were taking place in archaeology. A rich businessman, Arthur Evans, was interested in exploring the Aegean civilization, which was circa Bronze Age, and he managed to get permission and did excavations in Greece, and was famous for unearthing the Minoan palace of Knossos on the island of Crete. And he found that there was an entirely new civilization in which he was able to distinguish the Minoan civilization from the Mycenaean civilization. And he was not only that, he discovered artifacts and structures from that time, was able to identify the so-called the writing script called Linear A and Linear B at the same time. And this was obviously done with the assistance of local Greek scholars as well. But so this was the foundation of archaeology, and this was also, he was involved in the Royal Society. So as we talked about, not just in astronomy, in biology, and physics, advances were being made, but in other fields which are not recognized in the Nobel winners, such as geology, archaeology, and even map making were actively involved. So there was no item was exempt from Royal Society's involvement and support. Okay. Now, at the same time, we always talk about pure scientists, but the unsung heroes of science, or applied science, as we would call it, engineering, that it does not get enough credit. And the person who pioneered the engineering required as for part of Industrial Revolution was a very English-sounding name, a guy named Isambard Kingdom Brunel, and he was a son of an equally well-known Isambard Brunel engineer, who was obviously who was French and had settled in Britain and for a short time in America, and was a self-taught engineer. And subsequently, his son followed the father's footsteps and studied in France, and decided to work in Britain. And now the father had misfortune that he was thrown in debtor's prison, and subsequently he was talented enough and was involved in getting the Thames Tunnel project started. So the government had paid up some of his debts and was released. Okay, so that's a side note as to how harsh the capitalistic system could be at that time, that the laws were rather strict. Now, continued with Isambard Brunel, he outshone his father and was a pioneer in at least getting the Thames Tunnel started, various railways, various suspension bridges, and he was a shipbuilding par excellence, and kept building bigger and bigger ships. Then starting with the names which are the product of this time. The one was called Great Western. It traveled from Bristol to New York City as early as 1838. And obviously these were coal driven at that time, because there was no petroleum was not being used at that time. Secondly, and he again built even a bigger ship, which was called Great Eastern, which traveled back from Britain all the way to Australia, and at the same time there is no other venture that his fingers were not involved, and he was instrumental in building various tube stations, i.e. Paddington Station, and you can see the picture of the Thames Tunnel that was started. So he is, and the research and development that he was involved in was, way ahead of his time, and obviously, and there were equally other capable engineers, whose names are lost in history. But the one that needs to be mentioned was a guy named Henry Bessemer, who was a fellow of the Royal Society, and he patented a process for manufacturing strong iron, i.e. steel, and that helped, obviously, the engineering projects that were being carried out at that time. Okay, moving right on to the two giants of the field. The first one that we need to discuss is a person named William Thomson, who was a Irishman who had settled in Glasgow, and was a prodigy from childhood onwards. Later on, studied in Cambridge, and right from a young age onwards, he had worked on varieties of fields, including thermodynamics, measurement of temperature, and at the same time, you may recall that prior to that, in 1840s, telegraphy was discovered by Morse and other Englishmen at the same time. But Morse was the one who actually managed to get the patent in the United States, and later on, after some struggle, in Britain as well. Okay, now, so the idea came along with to improve communication across the Atlantic, and the project was undertaken by what was known as a telegraphic board to draw transatlantic cables. Now, the initial attempts were unsuccessful because the cable kept breaking. And so subsequently, William Thomson did the mathematical calculation regarding the resistance to the cable and the diameter of the cable, and challenged the engineers' concept who were involved in it. And subsequently, he was invited to join and make a trip on the cable-laying ships, and then subsequently on the second attempt was successful, and he managed to get patent for this, and obviously became independently very wealthy. And not only that, he put the science of heat, because as you recall, in industrial revolution, steam was important to improve the efficiency of engine and to understand the mechanism of heat and generating what is known as work, as to how to make the steam engines more efficient, was of great interest, not only just to the scientist, but to the industrialist as well. So that was the start of thermodynamics. And these are the laws of thermodynamics, which I consider uh, sacrosanct. And especially the second law of thermodynamics is that in universe, the entropy always increases, and that from order, any system goes to disorder. And the first law is energy conservation. Third law is about absolute temperature. And obviously, by this time, as William Thomson was knighted, and his subsequent name was Lord Kelvin, and this was his temperature scale, that the varieties of matter freezes. Actually, all the motion of the molecules ceases at absolute zero, and the temperature is remarkably cold as to minus 273 degrees of Fahrenheit. And so that is, very, and now this will become of importance when we talked about cosmic microwave background radiation. Now, one can say that the laws of thermodynamics, which are a cornerstone of modern physics, and obviously, I'm not going to give you the formulas and the mathematics of it, but one can interpret this, and a wise guy who had interpreted these three laws, as you can see that in the game of life, the first law is you can't win. The second law is you can't break even. And the third law is you can't get out of the game. Okay, so this was one of the cynical interpretation. Okay, so enough about Lord Kelvin. Okay, and for good measures, he had also discovered a lot of the other things, such as tide predator, but we won't get too much into it at this stage. Okay, continuing with our discussion, the second giant of that time is a person named Maxwell. I'm sure those of you who have had some background in physics may recall his name. And while all of us recognize the names of Newton and Einstein, when Einstein was asked as to whose work has inspired him, that on the shoulders of giants, as we talked about last time, that Einstein gave the nod to James Clerk Maxwell rather than Newton. James Clerk Maxwell was a Scotsman and had wealthy father, and again was a prodigy, had managed to finish college almost at 10 and had started publishing papers at age of 14. Okay, and had done pioneering work on combining light, electricity, and magnetism. Now, as this was done way before the concept of electron came into vogue. Now, obviously, all of us understand now that electricity is what you get when electrons move from one place to the other. Magnetism is when electrons spin around in same direction, and light is when electrons move from energy state, as the frequency and wavelength of the light. So these are the three basic principles of the three fundamental forces of nature. And the genius of Maxwell was that he combined this on a strong mathematical basis and showed the relationship of this. Now, obviously, the calculus, which Leibniz and Newton had invented, was the order of the day in mathematics. So he had formed varieties of complex equations showing So these are the classic laws that we study in so-called classical physics or electricity. Okay, and he published a set of equations which are known as Maxwell's equation. That all of these are so-called same forces, and we now call it as electromagnetic force. Okay, and he had varieties of interest, not only just the fundamental physics that he was interested in. He was interested in how optics or vision is perceived by human beings. So he was the first one who produced color photographs in the world, and the perception of RGB, the standard way of how light is perceived in the human eye. He had uh, proposed scientific ideas on that. Okay, and along with that, the breadth of knowledge was extensive. He had proposed what is known as a kinetic theory of gases, as to how the gas behavior is different at different temperatures. Okay, as to how the velocity changes, and so this shows as to how the classical something called how the two types of energies, so-called potential and kinetic energy. Okay, and now the other fields that he was involved in, some of the earliest work that he was done when he was in his 20s to propose and prove that Saturn's rings were made of water, and this was, obviously, and later on, subsequently, it was proven to be correct, and that they will eventually disappear. And for the physics buff, that this is a famous logo that people have skin tattoos of the Maxwell's equation. So unless you are well versed with calculus, don't think you would want to attempt to interpret this. Okay, and these are classified in the classical electricity Charles laws and Boyle's law. I'm sorry, Gauss's law about electrical resistance, current, and Ohm's law that we all studied in high school or middle school science. Okay, and the other two people, before we wrap up this session on Royal Society for this, the one person who was again a self-taught genius was a guy named Charles Babbage, and he had not gone to a formal university, but on his own he had studied mathematics and had written a letter to Humphrey Davy, who was the who is who of Royal Society, about devising a machinery to do calculation, addition, subtraction, all the mathematical tables, which were obviously the logarithm tables were around at that time. But he had proposed this idea of building a machine, and his ideas were taken seriously, and he was given funds. Along with that, he had managed to, for several years, he tried to manage the machine. Now, again, remember, this was before electricity. This was done with various gears, and it was a complicated, laborious device, a huge, almost filling the whole room with various rotating discs and gears to calculate various problems in mathematics, accounting, and shipbuilding, etc. Now, and subsequently, he had extended his idea to do something called differential engine to do various analysis. Okay, so now again, but he was perhaps ahead of his time, and even though his ideas were on solid footing, the machine actually was never put to work, at least in the 19th century. Later on, based on his design, people in 20th century have managed to replicate his ideas and build a working prototype of his Charles Babbage machine. And you can see that this man is turning the handle to see to get the machine to work. One of them is on demonstration at the Computer Museum somewhere on the West Coast. Okay, so this was able to do calculations of the various sequences of complex normal. So he was, and his assistant is even more famous than he is, who was a lady named Ada Lovelace, who was the daughter of I'm sorry, I'm blocking the mind, okay. Oh, Lord Byron, I'm sorry, that was, she's the daughter of Lord Byron, who was notorious in his own ways, and she had managed to translate Leibniz's work and was an able assistant to Charles Babbage. And now, as obviously women scientists were very rare, so she gets the nod and is celebrated as the first computer scientist of in the history. Another person whose work was still equally relevant is another self-taught mathematician named George Boole. The name may be familiar for those of you who are involved in computer sciences. This was the science of logic was around since the Aristotelian days. So he was a pioneer in putting mathematical analysis of logic. Now this may sound very odd as to put 1 + 1 = 0. And so, but this, for those of you who are familiar with computer sciences, they would realize that this is how the various statements can be, if the two in and or if and but, that if both statements are true, then both cannot be simultaneously true. So this is something called the formal logic analysis. This was much more elaborated in the by Bertrand Russell and Whitehead. They wrote the big tome of the logic of mathematics, and it took them almost 7 or 10 years to write the book, and where it takes almost 200 pages to explain why 1 + 1 = 2. Okay, so he was, and the Boolean algebra is still the ground, very involved in computer sciences, or the theoretical basis of computer sciences, and number theory, encryption, etc. So George Boole was way ahead of his time, and had put the logical analysis on a strong mathematical basis. And now, before the end of the century, another true polymath, there must be something about the time of the era that so many people who had absolutely self-taught as well as formally taught geniuses. The one who deserves to be mentioned was a gentleman named Thomas Young, okay, who was a true polymath in many senses. That he was not only a physician involved in mechanics, optics, and various languages. And what he's most known is what is known as a double slit experiment. For those of you who remember their high school physics will remember that as to light has a strange behavior as when the light, in this case electrons, but any light would do, it is passed through two lights instead of just getting two nice discrete shadows on the screen. We'll get an interference pattern. So for example, so whatever happens that the light changes and creates a wave pattern. So it's just almost like so this was the accepted theory at that time, that the light behaves as a wave as opposed to corpuscle as particles at that time. And not only that, he gets the credit for discovering the Rosetta Stone and deciphering the Egyptian script. He was a true polymath in the sense that he was fluent in various classical languages, all the European languages, and the Middle Eastern languages. So he was a man, was truly multi-talented. Now, again, to digress, that Royal Society even was open to invite the non-Europeans. And the one person who some of you may have heard about, but I won't assume that all of you are familiar with, is a guy named Srinivas Ramanujan, who was a poor clerk in the East India Company in what is now Madras or Chennai in South India. And he was a self-taught mathematician, had derived various theorems on what is known as number theory in mathematics, and his ideas were, his notebook was sent to the dean of mathematics at Cambridge, a guy named Hardy, and Hardy was impressed enough to invite this man, that this was, his thinking was way ahead of his time. Unfortunately, the timing of his arrival in Cambridge could not be worse. He arrived right at the start of the First World War, and was miserable in the cold and with the English diet, and had died of tuberculosis at a young age. And subsequent and more recently, a movie was made about his life, The Man Who Knew Infinity, that some of you may have seen or heard about at least. And the classic theories goes about is as to how he was able to just instantaneously analyze that number 1729 is not a dull number, but is a sum of two perfect cubes. And the oldest scientific journal that is in publication is for last 400 years almost is the Philosophical Transactions of Royal Society. And this is, one of the page from some of the earliest publications. So it is Transactions of Royal Society, Understanding of Studies and Labors, okay, of the Ingenious. Okay, so consideration of the word, and this was, starting from 1665. Now, obviously, they were not quite the first one. A French journal of the Journal of Savant was ahead by a few months in January of 1665, but it did not stay in continuous publication during the French Civil War or revolution. It was suspended. So one can truly say that Philosophical Transactions of Royal Society, and this journal is, obviously a very well-edited journal, and it is submitted by peer review rejections. And as I mentioned earlier, that even Edward Jenner's paper was rejected initially until he did, more detailed studies. So it's a very, the prestigious publications. And obviously, gradually even some women article were grossly were beginning to be accepted. And so these are some of the examples. And the first one was, we already talked about her, is Caroline Herschel. Okay, all right. So, and now again, from the continent, another person who was a true polymath of his era was a guy named Alexander von Humboldt, who was a German. Obviously, there was no Germany at that time, but he worked in Prussia, and he was a naturalist, and he traveled all across America studying the flora and fauna of that era, as well as the geology in Venezuela. Obviously, the travel was not easy at that time, but he made meticulous observation and collected huge number of specimens and did the natural analysis, and was one of the first one to suggest about conservation of natures. So, and had traveled through Central America and had visited President Jefferson in Washington. Later on, had traveled to Russia and had done remarkable work in what later came to be known as botanical geography, geology of that era. And a beautiful biography of his has been written by a German English writer named Andrea Wolf, Invention of Nature and the Heroes of Science. Okay, it's a beautiful piece of writing that I would strongly recommend for those of you who are interested in reading. And now, again, we talked about Hutton and James Hutton at that time, and but subsequently the Science of Geology was his work was built upon by a Scottish geologist who observed the rock formation in Scotland. And now at that time, the thinking was related to the religious thoughts about the biblical flood, which occurred a few thousand years ago before Christ. And that was the so-called catastrophism theory that was involved in how Earth had evolved. Now, this was in contradiction with what Darwin was proposing. So the Lyell's contribution to the science was something called gradualism, that the Earth was a lot older than what the religious authorities and some of the geologists at that time thought, and explained that this was a gradual process of various strata that were built and the gradual subduction of layers of earth took place, and with the igneous rock and the gradual climate change and the erosion of rocks that took place. So this was the whole of putting geology on a more scientific and a prolonged basis. So something called gradualism ideas, and his ideas were proved to be correct. And the idea of that just a biblical flood that created the earth, what finally fell out of favor. Okay, so this was at the start of the geology was coming into its own and was beginning a very vigorous discipline on its right. Now, obviously, those of you who have grandchildren may recall that many times you've been asked this question as to why is the sky blue? And later on, this has to do with the physics and astronomy and as to how the light travels. Because as you know, that the visible spectrum that Isaac Newton had proposed, has based on different wavelength of different colors. And the blue light has a shorter wavelength, which is relatively narrow. It is measured in nanometers, it's 10 to the minus 6 type of thing. And the red light has a longer wavelength. Okay, so based on that, as to how the light comes around and is reflected upon the water vapors from the sky. So this was one of the explanation for how the rays are reflected back, and that is the explanation as to why the sky is blue. And this was done by a chemist and physicist, Lord Rayleigh, who was not only worked on physics, but was also involved in discovering various elements. And along with the assistance of a chemist named Ramsay, they had managed to discover, obviously, this was shortly after Mendeleev from Russia, who had proposed the periodic table and the various elements that were discovered by Humphrey Davy at that time. So they built upon the work and were able to isolate the so-called noble gases. The first one that they discovered was argon, and subsequently their work expanded, and the so-called noble gases, which do not react with any other elements very easily, were discovered by Lord Rayleigh and Ramsay. And this was based upon varieties of other works on something called Tyndall effect, as to how the light refracts from with different elements. Okay, and this was again built upon the work of James Clerk Maxwell. Okay, so this was, the finding of so chemistry and physics were coming into the vogue type of thing. And again, later on, lower society was dragging their feet in allowing women's work to be published. And it took them until early 20th century until women became actively involved in Royal Society work. And these were the two crystallographers, who were later on some of the few early members of Royal Society. And the most recent awardee of the Copley Medal was a lady named Jocelyn Bell Burnell. And she was an astrophysicist working at the famous astroscope Jodel lab in Britain. And she had seen the pulsating, rotating movement of the stars. But now she was the assistant to another established astronomer named Hewitt Anthony. And again, they showed that the neutron stars were rotating on a regularly timed frequency. Okay, but her work was ridiculed at that time, as if they were saying that they were seeing so-called little green men who were flashing. And but subsequently, with further research, it was proven that what she was proposing, that the pulsating stars were, okay, let's see if I can zoom in on this further. And okay, so this was the pulsating moment that took place as to that when the neutron stars are so-called pulsating stars, which emit beams of radiation from the magnetic poles. They may not be precisely aligned with the rotational axis, and so this works like a lighthouse, so to speak, and so it looks like going through there as if they're turning light is being turned on and off. So this is, how the whole explanation of the neutron stars emission of light was proposed and proven. Okay, so this was some of the and so later on, so this is how you can just see how this is a GIF image. It shows how the light is transmitted and as perceived on Earth. Okay, and there are some other awards which are not as prestigious, but these are also recognized. And some of the names that you recognize are already familiar to us, but some of these other people that you may recognize, Elizabeth Blackburn was later on the ones who discovered the telomerase enzyme, which has to do with aging process. And Geoffrey Hinton was the pioneer of computer science or artificial intelligence. Okay, And now, again, we talked about the pure science, but there were other discoveries that were coming in one by one dramatically in the 19th century. So one can see that in the items that we recognize in our day-to-day living now were it dates back to the 19th century, starting from the electrical battery, which was discovered by an Italian named Volta, and that work was expanded upon by Sir Humphrey Davy, and to generating what came to be known as arc light. Fraunhofer lines was the how the lights behaves through various other elements such as sodium light, and that had a huge impact in astronomy. And from the medical field, René Laennec discovered the stethoscope, which is obviously has proved remarkably useful in health sciences. Sewing machine was discovered by various other inventors in Britain as well as in America. Obviously, the one who actually commercialized to a dramatic extent was Singer. Gyroscope was discovered by the Frenchman Foucault, and elevator was perfected and made more safe by Otis. And Carl Benz, okay, was a pioneer uh, uh, in automobiles. So that was the start of the uh, age for automobiles. On the other hand, some other inventions which did not turn out to be so well are well outlined on the side. Colt revolver, Gatling machine guns, torpedoes, and dynamite, barbed wire. So, okay, moving on to a couple of more slices. Moving on to the 20th century, the person who is known to a lot of you from the movie Imitation Game was the pioneer who broke the Enigma code, the German secret code, messaging code at Bletchley Park in Britain, and shortened the Second World War. And so not only just a mathematician, computer sciences, logician, but biologist par excellence. And their work was secretive enough and was kept in the shadows until 1974 by the British government. And unfortunately, as most of you know, he came to a very tragic end. He committed suicide because he was given sex changing injections because homosexuality was illegal in Britain at that time. Okay, so that was made into a movie called Imitation Game that I'm sure quite a few of you have seen. Another person who was well known because of not only just because of his research, a groundbreaking book called The Brief History of Time from Big Bang to Black Holes, and a theoretical physicist par excellence, and who worked on cosmology and was the so-called Lucasian professors at Cambridge, the chair that was dates back to Newton's era, and had worked on cosmology and Big Bang theory as well as origin of black holes. And there was a lot of complex mathematical analysis that was involved in terms of what happens in in the beginning of universe and what happens when stars collapse. Now, unfortunately, he did not live long enough until the existence of black holes was scientifically proven. And so that was one of the reasons. But he was perhaps even more popular than he would have been otherwise because of his disability due to amyotrophic lateral sclerosis, or so-called Lou Gehrig's disease. And last person who is I shall mention briefly, who is a Copley Medal winner, is Sir Tim Berners-Lee, who is a computer scientist who worked at CERN, which is the Large Particle Collider Laboratory in Switzerland, and as a means of communicating with varieties of scientists all across the world. They had built up the web server, or computer system for exchanging messages, which was the so-called hypertext, and the TCP stands for Transmission Control Protocol. And there was a starting of the World Wide Web in 1993. Okay, so he worked at CERN laboratory, and I'm sorry, it was 89. Okay, and to his credit, he did not patent it and was released it for humanities use. And so this was and the first browser that was created, in 1990, and the rest is history as to how we're all connected with each other. I'm not even going to talk about the mathematical part because this is complex enough. But then in mathematics, there are several problems that were unsolved, were proposed in the early 20th century. And one of them, well known, was called Fermat's last theorem. And a mathematician at Princeton finally proved it with an elaborate proof of it, and is a well-known mathematician. Okay, so but I don't think I'm going to talk too much about it. So we are finally finished with the Royal Society, and we'll continue next time with the Nobel Prizes as to what their impact on physics, chemistry, physiology, and medicine has been. So I'll stop my screen share at this time, and I will we'll continue next time. Thank you, everybody.